Good evening, my name is Yannick Magna, also known as Sakurina on the internet, and this is going to be a postmortem of Machine Learning, which is a game that I made with the help of my friends Woof and Godshot as part of the Ludum Dare 46 Game Jam. Machine Learning is a sci-fi themed life sim similar to the Princess Maker series. You can download it for free for PC, Mac, and Linux at the URL on screen. It takes between 45 minutes and an hour to beat. I mention this because this video will contain spoilers for the game, though I'll try to limit it to mechanical spoilers instead of narrative ones. You've been warned. I have no professional background in game development. Before last spring's Ludum Dare 44 Game Jam, when we released Sacrifice Battle, I'd never written a game that was made publicly available, and most of my private code were experiments with game dev tools that were quite limited in scope. I do, however, work in web development at my current job and spent 6 years as an independent iOS developer, so I'm comfortable with general purpose software development. Some of this video will talk about the development process of the game, but should stay at a high enough level that even non-coders can understand what I'm talking about. This video is more interested in the challenges inherent in writing games and the conceptual solution to those challenges than it is about the specific lines of code used to fix that problem, and it may be eye-opening to those who are curious about how games are made. The theme for LD46 was Keep It Alive, which sent us down a virtual pet or Tamagotchi route. For logistical reasons, this would have been a great project as all of us were working on the Monday of the jam, and we wanted to have something a little bit easier to develop because it would be more likely that we'd have something playable by the end of the second day. The idea got pushed a little more, and eventually we wound up in a more Princess Maker-y kind of concept. Here's how responsibilities were distributed amongst the team. Godshot designed the high-level game systems and wrote and planned the story. Woof handled creating assets, whether it be graphics, music, or sound effects. I did the coding and attempted to balance things in the game. This worked incredibly well compared to our past game where everything we needed to do was only spread across 2 people. I feel like with this spread, each of us had a more reasonable amount of work to do within a more limited scope, so context changes were kept to a minimum and we could keep our focus more often. And because of that, we could be more productive as a result. Here's how I would lay out the systems we had discussed and planned for this game at the start. You would schedule activities on a calendar, each with one or more associated stat growths. Each stat growth had 2 possible values, a default value and a critical value. Critical values would only occur at a percentage chance determined by your luck in that stat, defaulting at 10% luck. You could take lifestyle choices that would buff or diminish the luck stat of various stats. And through some combination of visible and hidden stats, you could achieve one of multiple endings. Now obviously if you've played the game, you know that the lifestyle choice system isn't in the final game, but it's actually all there in the source code. The lifestyle choice system was developed at the same time as the rest of the core systems, but I never got to make a UI for it. And we never really did come up with some flavorful lifestyle choice options, so it got cut due to time. Another thing that was discussed later but was never implemented was the possibility that at some point you could become proficient in a given skill, for example cooking, and then your luck rates for cooking related activities would go up naturally. This could have been done via the existing lifestyle choices system that was programmed, and it could have happened completely invisibly to the player without any UI development, but we just never did it. Here's a rough overview of how my 3 days were spent. So day 1 was spent mostly on gameplay systems. This was really about getting the basic gameplay mechanics working. I needed to be able to put things on the calendar, loop through each day of the month, and then apply the resulting stat growths to the character's stat sheet. By 4 p.m. on Saturday, every core gameplay feature that I ended up shipping in the final game were implemented, but at this point it would be with a very primitive and unattractive UI. Then day 2 was kind of story system and UI polish day. So start of day 2 was the implementation of the story system. Basically, these are scripts with every line of dialogue, and the story system would go through and loop through each of these lines of dialogue and render them in the dialogue pop-up line by line. The story system has built-in support for preconditions, which meant that we could theoretically have added story events to the calendar that are conditional on certain stats being above or below a certain threshold to play out. Originally, I thought this was going to be used for determining which ending you'd be seeing, but in practice, the way that stories are bound to days on the calendar was too limited to enable that, and it was easier to write a one-off exception than it was to rework the entire story system to allow a collection of stories to be bound to a day instead. Day 2 also had a lot of UI work. Woof sent me the color palette that I should be using instead of whatever colors I'd been using up to that point, so I changed those globally in my UIs. The schedule screen was quite hideous in its original state, so I redid the whole thing to be much more visually appealing. And this is also where most of the screens in the game became controllable with a mouse, and you'll be hearing more about that later. By the end of day 2, Godshot started having finished scripts for some of the story beats, so my focus kind of switched off of maintaining the code base and onto testing the story scripts to ensure that none of the lines crashed the game or that they were too long to be displayed. I also made a brief attempt at balancing the stat growths and requirements for various endings by theory crafting a bunch of things in a spreadsheet, and it led to some mixed results, which we'll talk about a little bit later. And then day 3, first of all, it wasn't really a full day since we were working throughout that day, but it was mostly focused around presentation. It was about implementing little things that made the storytelling experience better. I added some new declarations to the script file, so you could use #BG, #portrait, and #music to control background portrait and currently playing music from a story script. A very basic visual novel type stuff. Wolf made some sound effects that I sprinkled in a little bit where I could. I made a prologue screen, which was this minimal story player that could play a story chapter without requiring the entire game state to actually work, because that's how it works in the main screen of the game. This is how we played the story script prior to the menu screen. Godshot was sending in more completed story scripts throughout the day, and I would test them kind of like I did the day before to ensure that everything works. The endings were the last scripts to be completed, and I was hoping to test them all before we published the game. In practice, it took about an hour to get through the first test playthrough, and there were only about 2 hours left before the jam was over, so there was no way we were going to be able to test every ending in time. I was able to test that the scripts themselves worked, but I had no idea if the math I had done to balance stats on day 2 held up at all to a regular playthrough, or if there were any spelling mistakes that would trigger crashes when getting to the ending or any of that stuff. I jammed one last-minute fix in there to try to reduce overall game length, and that was to remove feedback dialogue from days with non-critical stat growth rolls. Prior to this change, you would have had to sit through a line of dialogue for every single calendar day. Now, if the stat growths are all normal and you don't roll a critical for that day, it'll just silently grant you the stat growth and skip to the next day. This sped things up quite a bit, but the game was still way longer than we wanted it to be. We were originally aiming for around 15 to 20 minutes, but by the time we actually got to test the full playthrough of the game, it was way too late to do anything at all about it. So let's take a moment to talk about stats. There are 7 visible stats in the game: strength, intelligence, charisma, dexterity, morality, trust, and stress. There are also 5 hidden stats, each for one of the main job endings: business, combat, research, cooking, and alchemy. As I stated earlier, the original intention was that the ending would be determined by a combination of visible and hidden stats hitting various thresholds. In practice, this isn't quite how it turned out. Visible stats are the only stats that are actually used for determining which ending you will obtain. So for the researcher end, which is the true end, you need to have intelligence above 90.6%, morality above 90.9%, and trust above 90.8%. For the salaryman end, you need intelligence below 35.4% and charisma below 50%. The chef end, unfortunately, is mathematically impossible. I just found this out a couple of minutes ago. Charisma needs to be over 127%, which is not going to happen, and dexterity needs to be above 90.6%. To be clear, this is a bug that I should fix. It's just I literally didn't even know about it until just now. Alchemist end needs intelligence to be above 90.6%, but not hit the other thresholds that were mentioned during the researcher end. And then Pirate end requires strength above 90.9% and morality below 50%. So then what's the point of the hidden stats? Well, the hidden stats are only used to determine which flavor of the character portrait is displayed throughout the game. There are 3 flavors: cool, cute, and passion, kind of like mobile games. Jobs can belong to one or more flavors, so combat and alchemy are in cool, alchemy, research, and business are in cute, and business and cooking are in passion. If the average gauge completion of hidden stats in a given flavor is higher than the others, that character portrait will be displayed. Every month or 2 in the story scripts, that state is checked again and the character portrait may change. If at any point during the game you max out the stress gauge or run out of money, you will automatically be taken to the bad ending at the start of the next month's planning phase. After we released the original version of the game, someone did find a bug with the salaryman end. There was a spelling mistake in a variable name, and that would cause the game to crash if you were likely to have that ending. Now, of course, it would only crash at the very end after you'd spent 45 minutes doing everything, so it was much less than ideal. We released a patch for that a day or 2 after the jam ended. Now let's move on to development. Machine learning was written in Lua for the Love game engine. Lua is a high-level language with really good performance characteristics, and Love offers a good multi-platform set of primitive building blocks for 2D games. None of this requires any special tooling, so you can develop without much trouble in whatever text editor you enjoy on whatever OS you'd like. I work on a Mac and my teammates are on Windows, so this was a very pragmatic choice for us. I do want to stress that I did say primitive building blocks. If you're approaching Love as a complete newcomer with no programming background, it can seem much more daunting than other game engines with more pre-baked modules, GUI tooling for configuring things, and wide communities to help you when you run into trouble. Now, don't get me wrong, I'm a huge fan of Love, and while it might not be the greatest for people who want to get their idea on screen and playable as quickly as possible from no prior experience, I think anyone who's interested in 2D game development should aspire to eventually understand and become proficient in tools like it. It's kind of shocking to me how unpopular it is given how much of a joy it is to use. Machine learning also wouldn't have been possible in as short a time frame as we had without relying on third-party libraries. TE Sound was used to have a simpler interface to sound and music playback. Both this game and our previous LD entry use a bunch of libraries from the prolific RxI. Classic makes traditional class inheritance models easier to use, and Lua. Lovebird is a fantastic debug console you can drop into any Love project. Loom is a series of helper functions that simplifies otherwise repetitive tasks. And JSON.Lua handles the saving and loading of the control file, which wasn't actually in this game because it got cut at the last minute. Whoops. We also use a library called Patchy, which can handle the rendering of what are called 9-patch images, or images with defined, safely stretchable regions, which we use within our game to draw the window borders for our UI. Now let's move on to the architecture of the game. Like Sacrifice Battle, this game makes use of a bare-bones layer system that I wrote last year. There's a layer manager, which keeps track of what layers are displayed on screen and what order they are stacked in. Each layer can have its own draw and update loops, input handlers, you name it, and there are flags to determine if the underlying layers should be paused or whether they should take input or not. This really makes it easy to compartmentalize different parts of the game into their own layer and try to keep the responsibilities of each layer to a minimum. As an example, here are the layers that end up being accessible by players in the final game. There's the prologue layer, which I mentioned earlier, which handles the pre-menu cutscene, the title screen layer, the name input layer, the main layer, this is where most of the game logic resides, schedule layer, the stats layer, and then the fade transition layer, which is used whenever we fade between screens. One of the issues I had with our previous game was how to structure code within the main game layer to deal with waiting on the completion of various actions. If you don't know about Sacrifice Battle, it was a turn-based strategy RPG, and this was a real problem because for each CPU character during the CPU turn, we'd have to choreograph this sequence of events, scroll the map so the character becomes visible, move the character one grid square at a time to its destination, display a combat animation, animate the impact on your unit's life bar, display your unit's counter animation, optionally display your unit's skill animation if it was invoked, animate the impact of the CPU unit's life bar. The way that was implemented in that game was a complete mess, mostly held together with callback functions. Almost every phase of that game loop was directly tied with its next phase, so it became very complicated to play them out of order. I realized it was a bad choice at the time, but ultimately it worked, and I was more concerned with making something playable within the time limit than I was in setting an example for code quality. Machine Learning is a much simpler game with fewer states to flip between, most of which revolve around presenting text to the player. Instead of using a callback approach like the previous game, the main layer keeps what's called a mode queue at all times. Whenever the engine's draw and update functions run, the behavior can change based on whatever the current mode is. If an action in a sequence is complete, or if it's interrupted by user input, it can remove itself from the queue. Then the next run of the update loop will handle the logic for whatever the new current mode is. So this is going to surprise no one, but here's the most common state in our game. The dialog window makes the current line of dialogue appear one character at a time. Once the entire line of dialogue has appeared, we wait for user input to move to the next event, whether it be the next line of dialogue or the planning phase of the game. So here's how that would be represented as a mode queue of 4 modes. Wait for text. This mode incrementally displays a string, removes itself from the queue if the player presses a button or the string is fully displayed. Wait for any input. This removes itself from the queue as soon as the player presses any button, whether it be mouse or keyboard. Story. This is interesting. It removes itself at the end of the currently loaded story script. If not, it pushes wait for text and wait for any input to the front of the queue with the next line of dialogue loaded. Now, it actually does a little bit more than that. As I mentioned earlier, there are like # declarations you can use to change portraits and background and music and all of that stuff. But basically, that's what it does. And then the last mode is planning, which is this fallback mode if the story script has finished playing every line of dialogue. This is the mode you are in if you are between months and you have to select your things that you will schedule on the schedule and have to press the OK button to resume the thing. And then the mode queue effectively gets reset to story and planning, and then it does its whole loop all over again. This queue-based approach actually made dealing with these kinds of waits significantly easier than the callback-based approach from the older game, and it was far more flexible and less error-prone due to how few dependencies there were between various modes. With the callback method, underlying game system's code needed to be shaped around various constraints and requirements to get it to work properly within that approach. The queue-based approach is comparatively a lot more grounded and sane, and generally, whatever system's code you write won't require any changes to work within it. This saved us a lot of time during development and meant that I could generally write systems much more quickly because I didn't have to constantly adapt everything to work within my flawed and fragile structure. All this added flexibility means that machine learning feels like it would serve as a good foundation that could be extended into a more full-featured game if we chose to do that, whereas Sacrifice Battle was so limited in what it could do that very little of the code would be salvageable. The last development-related point I want to cover is the controls in machine learning. So first, let's talk about keyboard controls. The layer manager that I wrote for our last game and reused for this one has built-in support for savable and customizable key mappings. There's even a key mapping screen built with 2 layers that are included in the source code for machine learning, but it's not accessible from within the game. The main reason I pulled this screen is that the entire game isn't playable via keyboard, so I didn't really see the point if that was going to be the case. There are basically only 2 things that are inaccessible via keyboard. The first is the button that kicks off the daily activity cycle. I simply forgot to bind this one to a key. There is no other clever reason for that. And the second thing that's inaccessible via keyboard is the activity selection on the schedule screen. Up and down were already bound to change what week of the calendar was selected, and left and right were used to switch between the various tabs of activities. There's also a challenge because the color we use for focus elsewhere in the UI is already being used to show which activity is selected for the selected week. So we'd have to probably put an indicator other than text color for keyboard navigation, and either way, we noticed this way too late in development to do anything about it with the time we had left. Because of these limitations, keyboard controls are really more helpful as shortcut keys to reduce the amount of mouse movement necessary to test the game effectively than they are as a primary means of controlling the game. Next, let's talk about the mouse controls. The granularity you get out of the box love mouse events is pretty much the mouse was clicked as this XY coordinate on screen. This makes sense because love has no UI framework of its own. There are no buttons or text fields to tie any events to. There's just whatever you draw on screen, and it's up to you to make them behave like buttons or text fields if you want to. What this means is you need to keep track of all the clickable areas on screen yourself and manually verify if the click matches up with any of their coordinates. Performance-wise, you should probably be keeping references to all of your rendered items rectangles anyway to avoid calculating them every single frame, though I still do this inconsistently myself. It can also be a little bit more of a pain if you have a dynamic number of clickable items whose layout can be reconfigured, or if you want to make your clickable zone bigger than the rectangle the asset is being drawn into. This is one of the things that really benefits from my layer manager approach to pop-up windows. Instead of having one massive click handler for every clickable item in the game, each layer can handle its own clickable items. When a mouse event comes in, the topmost layer gets to handle it first and decides if it wants to propagate that event to the lower layers as well. Similarly to how I streamlined the callback hell from Sacrifice Battle into the mode queue in this game, I would probably choose clickable items as something to streamline in a future game. The way I'm doing it in this game is honestly the simplest way possible, but it also makes the code kind of a mess, and it wouldn't be that hard to make a little wrapper that cleans things up significantly. So what comes after development? Well, it's publication, and I've got a bit of a rant for this one. Distributing a Mac version of machine learning this year was trickier than last year's, largely due to changes in the macOS security model that makes distribution of hobbyist software much more complicated. There are effectively 2 requirements to ship software on modern versions of macOS without going through the App Store, and those are code signing and notarization. Code signing has never been a strict requirement, but most Macs will refuse to run applications that weren't signed by default via the traditional double-click on the application icon method. If you want it to run on the first try on Macs with default settings, you not only need to sign your application, but it specifically needs to be signed with an Apple-approved developer ID certificate, which requires a $99 a year Apple developer subscription. What code signing enables is being able to tell if an app has been tampered with since it was signed, and if it has, prevent it from running in case it would do anything malicious. That said, if someone manages to steal your developer ID certificate, sign something as you, and publish it without you knowing, code signing isn't really going to help you. Now, before you say this seems completely implausible in the comments, this kind of thing has actually happened with one or two high-profile apps in the past, so it's a real problem. That's why notarization exists as a second line of defense. Notarization is a process through which you can submit your app to Apple's servers, where it'll be tested for various kinds of malicious exploits, and then registered on Apple's servers. When you try running an application on your Mac, it will be looked up on the notarization server, and if it's registered, you'll be able to run it. An application's notarization state can also be revoked if it's revealed after the fact to be malicious, meaning that Apple has a kill switch that they can use on any software that they deem to be malicious. There are workarounds to this stuff, but they are unintuitive and often resort to displaying super scary sounding alerts because, yes, in the end you are circumventing security measures that are meant to prevent malware. The problem is that the workaround didn't work this time, and it appears to be a new issue that hits love games particularly hard. So if you don't know, Mac apps are special folders called bundles that end in the extension .app and contain multiple files. When you make a Mac version of a love game, you drag your game's .love file into the resources folder of the bundle for the love runtime. Now, the love runtime is code-signed to allow it to run with no problems when downloaded from their website. And it contains an exception for the resources folder to allow you to copy your .love file into it, so everything would be clean and work. However, partial code signing no longer seems to be allowed in your versions of macOS. If you're all up to date on your OS updates, it simply tells you that the app is damaged and to put it in the trash. And the reason the workaround doesn't work is because it's not code signed. It's simply tampered with. So it just prevents you from launching it altogether. But of course, it never did that on my personal machine because I launched the application back when it wasn't tampered, and it only verifies code signing the first time you launch it, so everything was clear. The solution to this problem appears to be to strip code signing from the Love Runtime bundle altogether, using an undocumented flag to a command line code signing utility. A fixed build is currently being tested by the person who reported the issue, and we'll hopefully have it up on itch.io once we've heard back from them. But even then, it's not ideal. I would love to release a signed and notarized version of machine learning now that I've renewed my Apple developer subscription while trying to resolve these problems and be done with it, but now I'm running into issues on the developer site trying to get everything set up, so yay. If I do end up figuring all of this out, I will try to publish a guide somewhere so others can avoid the pain and suffering these issues have caused me. If you've made it this far into the video, congratulations. Before I go, here's some additional content you may be interested in. If you're curious about any of the implementation details in machine learning, you can find the source code on GitHub at the URL on screen. The soundtrack to machine learning is now available on Bandcamp at the URL on screen. There are also 2 episodes of my fortnightly podcast, Limitless Possibility, about game development related topics. One is about my first experience with the Love 2D engine, and the other is about my experience participating in Ludum Dare 44. If you've enjoyed this video, then you'll probably want to check those out. Thank you for watching this video, and I'll see you soon.